Okay, when last we finished, we had made a makefile, so now we're going to go back and finish writing our main function here in our source file.
Okay.
So prototype for this is always the same, even if you're not using the arguments. You always specify it, otherwise you get a warning.
And we all hate them.
Yeah. So we're going to have a couple of integers here, and we're going to have some format strings, which we're going to be doing alias wavefront obj format. And so basically these format specifiers are very specific because of how they like to have a face is all the vertices composing that face. So we're going to use quad geometry, so we're going to have 4 vertices in a face, and we're going to have a vertex format specifier, vert format, and basically again to specify a vertex for alias wavefront obj, and these 4 are integers, %d, because their index is 2 and 1, starting with 1. So the first vertex in the file is vertex 1 and 2 and so on. It doesn't start at 0, which can be confusing. But yeah, these vertices are actually floating point, and so we're going to have 3 vertices per, 3 components, an x, y, and z component for each vertex. There we go. That's correct. And we put a new line at the end of that's what the \n is. Okay, so first thing we really need to do is seed the random number generator. We're using the system's random number generator, which we will have to change, but for the time being we're using that because I guess we're writing this with the intention to eventually move it to something like OpenCL or CUDA, where we're running on the GPU. Right now we're just running on the CPU, but so in that case we have the CPU's standard library available. On the GPU you don't have that, so you'll have to use a statistical function that works with whichever technology you use to move to the GPU. So in any case, we don't have to do that yet, but just keep out for that. So we're going to start I at 0, go down through the number of bricks basically in X, and so that basically is going to give us an iteration over all of those. We're going to do the same thing for J in Y. We need a J there, a J here. And then, okay, so we'll end these off. So what we're going to do in here is set basically our temporary t to be I times in b plus j. Okay, so let's just see that we created this brick thread arg data, and there's up to ntd of these data elements. So we're going to pick the teeth element of data, and the t is basically based on where we are in this loop iteration, basically a function of I and j, so that we touch every one of them once. So basically what we're going to do is we're going to spawn a thread. So we use pthread create, and we've given basically the x and y coordinates in that data structure. So we also had created the thread pool here, and so basically we're going to use the teeth thread pool element for this thread creation. So each thread creation gets a unique pthread t for it. We don't need to specify that. We can see what that is, man. pthread create. That's a pthread attrib t, which essentially, if attrib is null, then the thread is created with default attributes. Default attributes are fine, so we're just going to put a null here.
Okay.
It's unneeded for what we're trying to do, so brick thread. Okay, so this is a function pointer to this function here, and that's basically the code that's going to get executed in this new thread that we're creating the brick thread. So that's what we're specifying there, and then we're going to hand it its argument, which is data sub t, which is what we just finished setting up for this one. And then that's the end of pthread create. I'm going to just shift this over so we can see it. There we go. Okay, so at least it's on screen, whatever. So now we've launched all the threads at this point in the program. So now basically what we need to do is ensure that each of the threads finishes before we proceed. And so we're going to basically start t at 0, go take t less than the number of threads, which is ntd, and then increment t. We don't need that doubly nested loop because we know how many threads there are. We just did that basically for convenience in constructing the argument for it. So now basically we're going to try and do pthread join, but if the pthread join fails on any of them, then basically we have to quit because one of the threads wasn't able to compute for whatever reason. So if pthread join on thread pool sub t and null. Okay, so if that, look at pthread join for a second here. The return value is what that other argument is. So if retval is not null, then it copies the exit status. We're handing null, so it's not going to copy the exit status. We really don't care. Okay, so we're just trying to do the minimal thing to continue, but we can throw out an error message if we like. Fprintf basically, like, we can put it to std error, and we can say error join to thread, this thread, and then basically put t, so then you get an error message and then it'll exit. We could give a failing exit status, but we really don't care. It's just exit. Okay, so now basically what we want to do is using the information that we computed in that kernel function, because all of those have run at this point in the program. All the threads have been collected, and now we want to basically print out an object file using the information. So this would be basically like a geometry shader if you were doing it on the GPU, but we're not, so we're just going to have it emit this format basically using the specifiers we created earlier. So we're going to go through each t from, so basically evaluate every thread's output. And what we're going to do for each one of them is emit a vertex, basically several vertices, all of the vertices for a cube basically for that object. Okay, so we have the vertex format is basically going to specify how. We need to give it 3 floating point things. So we need to give it data sub t's, position, translate x, and then we're going to move it around with I times bw. Okay, and then we're going to do the y with j times bh, And here basically we're going to do just .z, and then end that. 1, 2, 3, 4 lines we'll copy and do again, and this time we'll have a different z, and it'll be z plus the depth. And everything else I think will be the same other than that. So now we've got a doubly nested loop. It emits. Oh, so sorry, I didn't change this to J. This, I copied it from the other one. So we go from I 0 and 1, and for J 0 and 1, because once it's equal to 2, it kicks out. So basically, that's going to be 4 points, but then it's going to emit 2 things each time, so it'll emit a total of 8 vertices. And those are basically, there's 8 vertices on a cube. So now basically we've got the vertices in the file, and they get numbered essentially based on when they popped out. So as which order they popped out matters. Okay, so now we're going to go through each one of the threads item again. I mean, you'd think we already had a T0th to NTD, but the problem is we need all of that to run before we do the stuff here, because basically we need all of the vertices in the file before. I mean, we might be able to intermix them, but I don't know. I know it works if you do all of the vertices first. It'll probably could work, but I'm not even going to try it. If you intermixing vertices and face definitions, there's no reason to do that, at least not for this example. So
go with what works.
Yeah, exactly. So this time we're going to use the face format, and we want to, there's basically a way we can cheat here. We have to pick, we have to do a lot of typing. So basically if we use a macro, we can,
it doesn't sound like a cheat, but
yeah, we can use a macro and get a little bit less typing. T times 8 plus x. Okay, so let's hope that helps. Okay, so here we have to pick, and again we start with 1 rather than with 0, because that's the way their file format works. You always have to add 1 more than you would think with if you're used to working with 0 based stuff. But this is a letter O, not a number 0. I probably chose something horrible. We'll just call it F.
Yeah. Some people
because so we get
screen,
confused.
you know?
Yeah,
Unless
with a
you're,
font
like,
it could be
really
awful. Okay, so 3. Okay, and then F of 4. F of I'm killing it. F of 2. Okay, and then we have to double those. Okay, so we need several of these. We need 6 faces on a cube. So I have 1, 2, 3, 4, 5, 6. I have all the right ones, but I need to change the numbers in these other ones. So I'm going to go in columns because I have the right columns written down, which helps, but this is probably not helps for understanding why I'm picking these. But basically, I'm picking vertices that in an order that makes up the faces on the cube, and if they don't work, I've made a typo because the list I'm copying from did work.
Right.
So yeah.
Just accept this tiny bit of hand waving, unless you want to sit down with a cube
and yeah, map the vertices. It works.
We welcome you to do so.
If you do it, if you think consciously about it, get the rotation correct on all of them. I might not have that. I might have some clockwise, some counterclockwise. I don't remember. Okay, so I think I have what I like. 5, 7, 8, 6. And if we want to hoist this away, we could. It doesn't. We don't really need it away, but I mean, we could put it out here or something. It just needs to be before it's used. If I didn't make any severe typos, maybe just compile.